Okay, first we can see the basic problem, that is simple case. First, out of 6 beam, now we are going to study about simply supported beam. So in this problem, we are going to draw the shear force diagram and bending moment diagram for a simply supported beam with point load at center. First, we have to find the support reaction. Any beam, if it is of simply supported, we must first you have to see where the load is acting. It is acting at the center. How many loads are there? Here only one load, and that's also acting in the center. So half of the load will transfer to one support, half of the load will transfer into another support. This is your support reaction. How to calculate the support reaction? By using the equilibrium equation. So this is already I have explained in our class and how to calculate the support reaction. So here only one load, and that's also acting in the center. So the two supports will give the support reaction. If the external force is equal to the support reactions, then the beam is in equilibrium condition. So total load is P. One support has to give the reaction of P by 2 and another support has to give a reaction of P by 2. Okay. And then shear force diagram and bending moment diagram. This explanation I have given in your classroom. So this is the very fundamental shear force diagram and bending moment diagram, and also the value is also very important. So simply supported beam with a point load at center, the maximum bending moment will be in center because only one load is acting and also it is acting in the center. So maximum bending moment will occur in the center. The value of the maximum bending moment is WL by 4. You can see in this diagram. So this is the next case, simply supported beam with the uniformly distributed load. So from you can see in the diagram from A to B, A is a hinged support, B is a roller support. From A to B, the load is uniform, that is W kilonewton per meter. So in UDL, you have to take the total load. Total load how much? W is acting for a span of L. So the total load is W into L. Whereas in the point load, the load is acting on the particular point only. So only that is mentioned in Newton or kilonewton. But here you can see W kilonewton per meter. So you have to convert the UDL into total load, that is W into L. And also it is acting at a distance of L by 2. So how much distance is acting, that you have to see. You have to multiply the load with the acting distance, that is total load. That total load will act at a point for the distance by 2. So you can so here the total load is W into L. It is acting in the center. So half of the load is transferred to one support. The half of load will be resisted by the another support, that is WL by 2, WL by 2. This is your support reaction. Both are same. You can see. And shear force and bending moment diagram. So these are things I have already explained in your class. And the shear force is maximum at support and bending moment is maximum at center. The relationship between shear force and bending moment is, if shear force is maximum at the point, bending moment will be 0. If the shear force is 0 in a particular point, in that point bending moment will be maximum. You can see in the diagram. In the first diagram is shear force diagram. You can see at the center the shear force value is crossing, that is plus positive direction, positive side to negative side. That means at the distance of L by 2, the shear force value is 0. You can see the bending moment diagram. Bending moment value is maximum at center, that is L by 2, WL square by 8. That means what? If the shear force value is 0 in the particular point, the bending moment will be maximum in the point. This is a relationship between shear force and bending moment. If the shear force is 0, bending moment will be maximum. If bending moment is 0, shear force will be maximum. You can see in the bending moment diagram at 2 points, that is support points, bending moment value is 0. But you can see in the shear force diagram, in the support point, the shear force value is maximum. That is WL by 2 positive and WL by 2 negative. This is the relationship between shear force and bending moment. So here instead of value W, here the basic problem. It's a simply supported beam carrying a point load of 20 kilonewton at center. The total span of the beam is 6 meters. So as already discussed, the support reaction will be, total load is 20 acting at center. So support reaction will be 10. 20 by 2, that is 10. And reaction, sorry, shear force and bending moment diagram, you can easily solve by using the previous cases and draw the shear force diagram. And bending moment value is maximum at the center because only one force is acting, and that too in center. So if you understand the concept that we have discussed so far, you have to solve this problem and upload your solution. You have to solve on your own, on your own handwriting in your classwork note or a A4 sheet, and you have to submit it as a PDF format, PDF document in your Sprout LMS before 5 p.m. on 8/8/2026, that is Saturday. So this is your simply supported beam with 2 point loads. So before solving the assignment problem, you can also refer this problem. This is for your reference. If you understand the concepts, you can easily solve the problem. Here I have given for 2 point load. You have to solve for 3 point loads. Okay. Thank you, students.